Okay, so this is the second part of our CCNP IPv6 class. So in part 1 we did basic IPv6 addressing. We went over the link local addresses, the global addresses. Don't remember if we actually did tunneling. That was like 2 weeks ago. And plus I've gone through a CCIE boot camp, so my brain's kind of frazzled right now, but I think we did tunneling, or maybe we started tunneling. So you'll find the class notes on routergods. If you go to training and class notes, you'll find it down here, IPv6 part 2 class notes. And when this session is over, I'll upload the HD Hangout recording and you'll be able to watch it later if you want. So that'll take about 2 to 3 hours after the class ends. And just let me know in the chat room when you have your routers online. They don't need to necessarily have the IPv6 addresses, but just make sure you're at the prompt here, just like you see on my screen. So our first order of business is to pop some IPv6 addresses on our routers. So we're going to go on R3. Go on R3, do a show IP interface brief. These are your IPv4 addresses. If you have those, that's fine, not a problem. If you don't have IPv4 addresses, that's also cool, because it really doesn't matter since we're doing IPv6. So first order of business, we're going to turn on IPv6 Unicast routing, because if we don't do that, things are going to scream at us. So actually don't turn that on. I want you to see the error that pops up when you try to enable these routing protocols, because it will say something. It will let you know that you forgot to type something in. So we'll leave it out for now. And if you look at your topology, you'll see that you've got R3. Let's configure the link from R3 to R4. So R3 to R4, that's fast01. So interface fast01. We're going to make a link local address. If you look at your class notes, it's a pretty easy format. So it's IPv6 with space, IPv6 address, and link local addresses are FE80, and we'll put 2 colons in there, and then we'll put the number of the routers. So if you're on router 3, which you should be, it's be ::3, and then add the word link local to the end. So FE80 ::3. And then just go on all of your other interfaces, hit the up arrow, add in the same link local address. Okay, so we're still on R3. We've popped in an link local address, FE80 ::3. Narbic calls this Fady, like a name of a girl, Fady ::3. I guess other people have names for it too. So fast00, fast01, and do a loopback 0 with the same link local address. Not a big deal because all you're doing is hitting the up arrow. Let's see what else we have for R3. Fast10. So you've got link local addresses on 3 physical interfaces and your loopback. We didn't necessarily need to do this. We're just doing it because we don't want those ugly EUI64 addresses for link local addresses. So after link local addresses, we're going to do some global unicast addresses. So let's take a look at our diagram. So R3 is between R3 to R4. That's on the fast01 interface. So go back to interface fast01. IPv6 address. And the format we're going to use is 3000 :1 :1. And for this fourth, it's not really an octet, but for this fourth part, it's the numbers between the 2 routers. So if it's between router 3 and 4, it's going to be 34. and that's going to be the network portion. We're going to do a double colon because that's going to be a bunch of zeros. And now for the host number, we're on router 3, so we're going to put a 3 there. So the 3 at the end signifies your router number. And we need to tell it how many bits to use for the network, so we're going to be a /64. So IPv6 address 3000:1:1:34:3. I'll actually paste this into the chat window, that way you can be extra careful, or as a kind of like an idiot check there. Geez, and Google takes one of those 3s and turns it into a happy face. Okay, you could put your cursor over it and change it back to 3. Okay, and then what you could do is go to fast10. Fast10, this is the link between R3 and R5. So interface fast10, IPv6 address 3000:1:1, and it's between 3 and 5, so it's 35:3/64. And let's give our loopback an IP address, an actual IP address, global address. We'll do IPv6 address 3000:333:3. So basically a bunch of 3s /64. And if you want to look at your interfaces, show IPv6 interface brief. You should see your link local addresses right there. They're all going to be the same, FAD::3. Your global unicast addresses 3000:1:1:34, 3000:1:1:35. And I'll paste this in the chat window as well. So that is R3. Toughest part about IPv6 is typing all these addresses in. Thankfully, when you take the lab for CCIE, usually they'll be typed in for you. Looking at our diagram, we're going to be running RIP in our inner triangle here. So let's start RIP on fast01. The thing with IPv6 RIP or RIPng is that you start it on the interfaces. So it's a little bit different. Actually, that part is very different than IPv4 RIP. But it's pretty easy. All you have to do is go into conft interface that you want to configure it on. So interface fast01. So I like to do the show IPv6 interface brief before I start, because that way you could refer up here while you do your commands. So you look up here and go, okay, fast01 is the one I want to go to. And that one, looking at that fourth part there, 34 means it's between routers 3 and 4. So it just gives you easy reference. It's very simple. IPv6 RIP. Then if you do a question mark, it's asking you for the instance name. So this is pretty interesting as well. You can have multiple instances of RIP. Just like you can have multiple instances of OSPF, in IPv6 you can have multiple RIP. So you can call this whatever name you want. This is locally significant. I'm going to call mine orange chicken. And then if you do question mark, you have a couple things you could do, but the easy one is enable. Enable will turn it on for that interface. Now for those of you who are curious, and you see that first option there, default information, you probably guessed it right. That probably throws in a default route. And we're going to do that later. And you hit enter, and yeah, so it tells you IPv6 routing is not enabled. So that's the error it's going to tell you. So not a big deal. You can exit out of there. IPv6 Unicast routing, that will turn it on. Go back into your interface, hit the up arrow a couple times, and get back that RIP statement, and you're good to go. Let's take a look at our diagram again. So we have activated RIP on fast01, so that's cool. Let's start it up on fast10. And we also have a loopback, so fast10 and the loopback. You pretty much just hit the up arrow, IPv6 Rip, the name and enable. Go into your loopback, hit the up arrow, and throw your RIP statement on there as well. Verification, just like in IPv4. So in IPv4 we had show IP protocols, IPv6 show IPv6 protocols. Shows we've got RIP. It gives us our instance name. We have a loopback, fast10, fast01. Show IPv6 RIP. Let's see here. So shows our RIP process, port 521, multicast group, admin distance, same stuff. Maximum pass 16, updates 30 seconds. So everything is pretty much the same. Split horizon works normal, poison reverse, everything is the same. It's just the addressing is a bit uglier.
Did we do all interfaces on the router 3?
You can if you want. You don't need to. I did fast01, which is towards router 4, fast10, which is towards router 5, and the loopback. So I did that guy, and the loopback. But if you also want to start RIP over here, that's fine too. You get extra points. So while I'm waiting for some of you to catch up, let me tell you about that CCIE boot camp I took. It's one hell of a boot camp. No PowerPoint, no projector. Narvik just writes everything down with dry erase marker. He knows every iOS command down to like all the sublevels. So that's pretty darn good. There was also, let me pull up a picture here. I'll have to go into my Facebook. So for RTP, real-time transport, there are payload numbers, like a whole bunch of payload numbers, like 3 dozen I think, in RTP. And he wrote down 17 of them from memory when he was teaching us. So see right here, he started writing down all these protocol numbers up on the board. So what I did is I pulled up the IANA assignment sheet for all these and just, you know, I was a bit skeptical, and every one I checked out was correct. So he threw up 17 of them, they're all correct, and then we started asking him questions like, well, what about this one? We're just throwing things up just to see if he would forget, and he got every one. So that was awesome. So the guy definitely knows his stuff, and he allows unlimited.
It sounds like he's a ball of energy too.
Yeah, yeah. So he allows unlimited retakes. It's 3,000, but you know, if you take it twice, it's 1,500 each. You know, it breaks. That's what it breaks down to, and yeah, it was awesome. I liked it. And I'm writing up a full review of it, so you'll see that and all pictures come up. So the question is, does he teach full-time? Yes, he does. He teaches full-time now. He used to consult a lot, and now he spends, last year he spent 40 weeks on the road teaching.
Now the real question, do you feel closer to ready for the CCA lab now?
Oh yeah, yeah. Actually, I did all of Aine's workbooks in preparation for his boot camp. He does send out his foundation workbooks that you're supposed to do. It's like his version of workbook 1 for Aine. And you have an assessment lab, the official Cisco assessment lab, on the first day. And the average score was abysmal. It was like 52%. Might have been, it's like 50 something percent. I got a 72, which I thought was pretty good. And he's like, yeah, it's actually like a really, really good score to have a 72 on your assessment test. But that only covers up to BGP. So it's just to see kind of where you are later in the week on a Thursday night. So that's what's crazy. A Thursday night, you take another assessment lab. It's a troubleshooting and config, and that starts at 8 p.m. So you stop at 4 a.m., which is pretty nuts. But yeah, towards the end, we're just like, F it. We already failed this. So it's pretty bad. I'll just eat the points on QoS. It's like, no. But yeah, it's pretty good. Okay, everyone's cool with R3, right? So just to verify, R3, show IPv6 Rip. Should have at least 3 interfaces in there: the loopback, fast10, fast01. Okay. All right, so nothing too exciting is happening now because it's just on R3. But once we start configuring RIP on R4, we should see some extra stuff in there. And we can start it off. Stay on R3, show IPv6 route. You know, these are just your connected interfaces and you know, connected and local. So these are your interfaces. So if we start configuring RIP on R4, we should see some R routes pop in there. So let's go to R4. First, we're going to do some link local addresses. So let's make sure we're going to do fast00, fast01, and a loopback. So int fast00, link local addresses, fady, : 4. Oh. And so 0001 and the loopback. And Notepad is very, very helpful for IPv6. Now we're going to do our, well, if you're in your loopback, you might as well configure your loopback global address. So it's 3000,444:/64. So basically a whole bunch of 4s. Go back into your fast Ethernet interfaces. We're going to pop in our global addresses. So IPv6 3000:1:1. This is between 3 and 4, so it's going to be 34. : and then our number, we're on router 4, so it's going to be : 4/64. Oh, gotta remember to pop in that word address in there. I seem to forget it a lot. So fast00, we're good. Fast01 is between R4 and R5. So 3000:1:1, 3 and 5 is going to be 35:4. And so you should have those interfaces configured. I'm going to paste this in the chat just in case you need to catch up. So yeah, if you look at your topology, oh shit, yeah, should be 45, shouldn't it? That's okay, we can fix it. So the thing we have to be careful about, I meant to do that because I want to show you that you have to nuke it, because if you just added another IP address, it would just add it without a problem. So this would be 45::4/64, and now we should be okay. So I'll let you guys catch up for a couple minutes. Oh, let me show you a screenshot from so the troubleshooting part of that boot camp. You get a part of that assessment. I'm going to show you something really dumb. Absolutely, completely dumb. So one of the troubleshooting tickets, actually the first one, is getting frame relay to work. Right? Trying to get OSPF to work on R9, R11, and R12. There's frame relay in the middle, and basically our whole class was stuck on that for, like, it was, after 30 minutes you're going, what the hell's going on? And turns out along the top is your control panel. Notice how some of these are red. And what happened here is, for some wacky reason, on like everyone's pods, just random things were turned off. Like you would expect, this is a virtual lab because troubleshooting is done on IOU. Like all of them would be green, turned on, but they weren't. And you'll see towards the end on this second row, FRS is the frame relay switch. So frame relay switch was off. It's like, dude, that kind of sucks. But if you take your real CCIE lab and the troubleshooting portion, just turn everything on, just like right off the bat, save yourself time, turn everything on, because don't count on them having all of your devices turned on. Yeah, that was something I thought was really dumb. So that's not NARBIC's fault, this is Cisco's fault. This is Cisco's assessment lab. All right. Okay, so we got IP addresses on R4.
So Cisco has their own lab that they let us log into or charge to log into?
Yeah. It's so NARBIC is part of the
cool.
360 program. So as part of the 360 program, he gives out the official Cisco assessment lab, which is the 6-hour one on the first day. And he gives out the assessment lab number 2, which is troubleshooting and mock lab. You call it a mock lab, on Thursday. And so he uses those two as a gauge of where you are and how much you've learned so far. And then in between all of that are his lectures. So that's a supplement. But yeah, for the whole week you get access to a Cisco rack in addition to NARBIC's rack, which is pretty nice.
Nice, so it sounds like he didn't even allow you have time to sleep.
No. So the question is the CCIE exam now on I'm going to guess IOU. The troubleshooting is on IOU. That is a confirmed. That is on IOU. The real lab is still, the config portion is still on regular gear. Although the rumor is they may change it to like everything will be IOU, but the problem is they haven't worked out all the bugs yet from IOU. Okay, going back to R4, we have to turn on IPv6 Unicast routing if you haven't done so already. And now we're going to fire up RIP. Let's take a look at our diagram here. Got R4 to R3, that's going to be fast 0, 0. So before we do that, let's do a debug. Let's debug IPv6 Rip. Okay, let's do that. Go back to fast 0, 0. So it was IPv6 Rip and a word. I'm going to stay with the same naming. Enable. You can pick another name if you want, just to prove to yourself that these are local. So all you're doing is turning it on. You could see RIPng fires away. We've got some updates. Have some responses. We see stuff coming from R3. And right here where you see inserted, this means you're getting stuff from the other side. So it looks like things are happening. Let's go into our loopback, interface loopback 0, hit the up arrow a couple times, start RIP over there. And int fast01, start RIP over there as well. And Jesus, stop this debug or else it's going to drive you crazy. Alright, if you show IPv6 route, you'll see RIP routes. And you should see, let's see what we got here. You got your stuff in there. Okay, 3000:3:3:3, and then there's going to be a 3 after that. So that's the loopback address of R3. We should be able to ping it. So ping 3000:3:3:3:3, and we have a success. Let's try trace over there. No, that was easy. Now if we do a debug IPv6 packet and do the ping again, you'll see that it goes out your link local address. So you all on that. So let's see, it got buried in here somewhere. Destination 3000:3:3:3:3 FE80. So you see all these FE80:3. Those are the link local addresses. So it takes the global address, finds the link local address for the next hop, fires it off, and each router along the way does the same thing. So pretty much acts like RIP, like it's normal, not a problem. Any questions so far? We've just done RIP on R4. Timers are the same, everything else is pretty much the same, just the numbers are different. Okay. Let's see. Let's hold off on R5 for now. Let me show you the default information originate. So R4, let's just take a look at its routing table. Show IPv6 route. Normal stuff, nothing too big. We're going to go on R3. We're going to do default information originate on fast01, and that's going to send out a default route towards R4. So we'll go on R3, int fast01, and then IPv6 Rip, and you do a question mark. You have to put in the instance that you're messing around with, default information, and then you could put originate and then a metric, like 5, let's say. Okay, after you type that in, go to R4, hit the up arrow. Let's wait a little bit. Bless you. There we go. After you wait Rip's most awesome, 30-second timer. You'll see right here on R4, we've got an R route here, ::0, :/0. That means default route. We have a metric of 6, and that's because we've got 5 in there plus 1, right? So it started off as 5, added 1, and now it's at 6. It's telling us the link local address to get out there, which is the link towards R3, or on R3. And it's telling us the fast00 goes out that way. So, default information originate works pretty much the same, except that you're configuring it on the interface. Alright, you guys want to go through configuring of R5, or you think you're good with RIPng? The failover is going to work the same. We could start up on R5, kill the link, and you'll see it go around to the other side. Yeah, it's not that exciting. It's the same thing as regular RIP. Okay, so let's try OSPF. OSPF is pretty fun. We can leave the RIP in there because it's got a higher administrative distance, so OSPF with 90 is still going to win. We have all of our IP addresses on R3 and R4, so we don't need to do that, so this should be pretty quick. First thing with OSPF version 3 is it's a really good idea to put in your router ID first. And you'll notice something with OSPF is that it will use an IPv4 looking router ID just like normal, just like you see now. And if you have all IPv6 addresses, it will scream at you a little bit. So right now we've got IPv4 addresses, so we're not going to run into that problem. But if you go into conft, so in OSPF before with IPv4 it was router OSPF 1, right? With IPv6 it's going to start with IPv6 router OSPF, and then you pick a process number, so we'll say 1, and enter. So you're in IPv6 OSPF or OSPFv3, do router ID, and it's the dotted decimal format, so 3.3.3.3. Now if you end out of there and show IPv6 OSPF, you'll see that your router ID 3.3.3.3. So it's not an IPv6 looking address, it is the traditional number that you all know. So that's why it's always a good idea to put in a router ID before you actually start any OSPFv3 on the interfaces. So see the timers and everything else, that's all the same. Reference bandwidth, still 100 megs a second. It still has stub area, it still has NSSA areas. That does not change. That's all the same. Alright, let's go on to the interface. We're going to be going on fast01, IP OSPF, IPv6 OSPF 1, area 0. You can add in an instance number, but we'll just say enter right there. IPv6 OSPF 1, area 0. So just start area 0 OSPF on all your interfaces. And also your loop back. And staying on R3, end out of there, show IPv6 OSPF database. And you'll see that you have a type 1, the router LSA, that's pretty much normal. You'll notice a type 8. That's interesting. You'll have another one called intra-area prefix link states. That is also known as a type 9. So type 8 and type 9. I'll explain later what those mean. They're not too complicated. They're actually pretty easy. Okay, so we have OSPF running on R3. No big deal. It's easy. Go to R4. conft IPv6 router OSPF 1. Router ID all fours. And then just go on all of your interfaces, IPv6 OSPF 1 area 0. And you'll see when you start up on 00, you'll see that your neighbor comes up just like normal, just like regular OSPF does. Okay, we'll end out of there, show IPv6 route, and you can filter it by OSPF. So let's take a look at this. We're looking at the O route for 3000:3:3:3 :3. That's the loopback of router 3. That's coming in as a /128, but I'm pretty sure on the other side we have that interface should be a /24. Show run int loopback 0 or /64, right? So it's a /64, yet it's coming in as a /128 when we're looking at it on router 4. So what's happening here? What does OSPF do to loopbacks that we saw in the IPv4 OSPF? Yeah, so it's looking at it as a stub host, so it's converting that into the longest mask number of bits that it could do, so it's 128. How do you change that? It's the same deal. So we'll go to router 3, conft, go into interface, loopback 0. So IPv6 OSPF network type point to point. And that's going to tell the router to advertise that as the normal mask. Go over here to R4. And now we see that as a /64. Turns it back to normal. So this is the same as regular OSPF. Not a big deal. If we take a look at the database here, show IPv6 OSPF database. So we got our router link states, LSA type 1. So we could do show IPv6 OSPF database, all threes. Oops, sorry about that. Router, all threes. Link state ID, advertise a router. We'll just do that. How about that? Show IPv6 OSPF database router. Got all these bits set. Router links. So this looks pretty much normal, except there's some extra bits that are new. You have your type 2 just like normal because there's DR and BDR stuff in here. But what's really cool is the type 8 and the type 9 LSAs. So let's take a look at the type 8s that you see in your database. As you can see right there, this is pretty awesome. We have, it looks like from this interface column here, that these are linking to the interface, and we should be able to look at them. Show IPv6 OSPF database, do a question there, link, we'll hit enter, and hit space a couple times just so you see everything. So let's see what we got here. So looking down here, advertising router, you can see which router is telling you about that particular link. So if we look at this middle one here with 3.3.3.3, yeah. It's interface fast00. It's telling you the link local address of that guy, number of prefixes attached to him. This is the global address on that particular link and the prefix length. So this is giving you all the information of that particular link, hence the name link LSA. Let's take a look at the database again. Those type 9s. So if we show IPv6 OSPF database, prefix, and so these are the type 9s. Intra-area prefix LSA. Let's take a look at what this says. Tells us it's coming from router 3. Referenced LSA type, so it's basically looking at another LSA. Reference link state ID, I don't know what that is, but it's basically telling us that router 3, it's got one prefix there. That's the prefix it's telling us. Here's router 3 again. That's the prefix it's telling us. All three, so that's the loop back. And we have another one, which is the link between router 3 and router 5. So why do we have these extra LSAs? Well, when they were kind of rethinking OSPF for IPv6, so they went back to the drawing board and they're looking at how OSPF normally handles everything. So let's say this was all in OSPF and this was all area 0. What happens to OSPF if, let's say, I add a loop back there? So everything's running OSPF, I add a loop back on R4. What's going to happen to the SPF calculation and the CPU usage on all of my routers inside this area? Will all the routers in my area do a recalculation? Yes. So you add a loop, you add an interface, you take out an interface, some interface goes down. Basically all the routers in your area go nuts for, a little bit, and then they figure out, they churn through the SPF algorithm, they find out the answer, and then they're cool. So with IPv6, what's cool is that these two new LSAs contain the information that says, okay, we've got these routers, we've got these links attached to them, we got these interfaces, so it cuts down a lot on the SPF calculation. We've included a lot more information there so that SPF doesn't need to work as hard. So our convergence, hopefully we can converge a lot faster, and we're not twiddling our thumbs so much. So the goal here is to add new interfaces or take out interfaces without having our routers go through SPF at all. Because all this information on how to get there is already listed in the type 8 and the type 9 LSAs. Alright, any questions about router 4? Any questions about the LSAs or starting OSPFv3 on this? It's pretty simple. If you know OSPF in IPv4, you can figure out OSPF in IPv6. These two new LSAs, that's really basically the only thing that's different with it. There are a couple other things, but for the most part, that's about it. All right, well, that was easy. I'm going to stop the recording here. And so that was part 2 of IPv6 CCNP route. Going to stop the recording and now we'll chat.